Good day. The concept of multi-hazard risk management is not a new idea and has been around since 1970s. But when we look at the recent literature, we can find two strands of research. One related to governance structures and decision-making processes, and the other one is related to evaluating the interactions between hazards and exploring potential synergies and trade-offs. So in the introduction part, we argued that these two concepts need to be addressed simultaneously. In this paper, we decided to set a knowledge base, a kind of foundation upon which our final multi-hazard framework and decision support tool will be developed. In sections 3 and 4, we started with single hazard perspective. Why? Because while our focus is on building level interventions, the final goal is to apply these strategies in a citywide portfolio. And in this case, not all buildings require integrated measures. In section 3, we presented and categorized the most common seismic intervention methods, both for RC and URM buildings. We also provided more detailed information in supplementary material 2. For instance, if you would like to know more about TRM, you could find explanations in this document and under the URM section, and here it is. In section 4 and supplementary material 3, we used the same approach for most common flood risk reduction measures. Here, we acknowledge that a comprehensive flood risk management solution should encompass several different types of measures like MBS, non-structural, structural. But since our objective is building level integration, we mainly focused on building level measures with very little explanations of other measures and their interactions with building level ones. All of these measures are compiled into a catalog in supplementary material 1, which after some modifications can be integrated with the decision support tool. Currently, there are 4 parts in this database, 2 related to decision variables that are used in measure selection procedures, and 2 related to risk reduction measures themselves, which are categorized using several different attributes to make our life easier in selection procedure. And of course, this is a living document and will be updated as we proceed. In section 5, we provided a kind of comparative assessment of these two hazards and highlighted the differences in hazard, exposure, vulnerability, tail behavior, spatiotemporal changes, and correlations in the risk profiles. When we are dealing with both of these hazards, this understanding becomes crucial for a sound decision making. Section 5.3 is the core of our work, in which we explained how these interventions can be integrated or combined. Integration means that we use the same material with a slight modifications to serve both interventions, but combination means that we use the same workforce and site mobilization to overlay both interventions. Then we introduce the synergies and trade-offs of various intervention methods. Finally, in section 6, after synthesizing the common decision variables used in intervention selection procedures, we discussed why these decision support tools are not well suited for a multi-hazard landscape. And as a way forward, we proposed additional decision variables across different categories, including technical, sustainability and environmental, and social aspects. Thank you for your time.